Dr. Jaffe, I'd like to know a little bit more about how potency guard is produced. So I know we do a triple recrystallization and we also process it under a nitrogen blanket. But can you explain to us the actual process from the plant source that we get it from till we actually get to the powder?
Well, depending on the time of year, the carbohydrate source will be different. But what we have is an organism that exists in nature that produces ascorbate in the course of its natural metabolism. The reason that we produce it under a nitrogen blanket is because ascorbate, normally produced in air, is damaged on the way to being produced. So we need to have an organism that is able to produce ascorbate, a reducing substance, an antioxidant, without oxygen being present. So it's an anaerobic organism. It's an organism that loves to be without oxygen, and actually, if you introduced oxygen, it wouldn't be so happy. So it's a fermentation process under a nitrogen blanket, and then, even though you have a very high concentration of ascorbate in the fluid, in the supernatant, you really want to completely and easily separate the ascorbate from the organism that produced it. So you filter it. It's a cold filtration. So you separate the fluid from the organisms. You leave the organisms behind. You leave anything of larger molecular weight behind because your filter only allows tiny molecules, and ascorbate is a tiny molecule, to come through. And then out of an excess of caution, we recrystallize that 3 times so it gets purer and purer and purer to reach the quality that we at PERC defined as sufficient and necessary for producing a biological, a safer and more effective ascorbate suitable for the sea cleanse, suitable for long-term use, suitable because it's fully buffered, fully reduced, and fully bioavailable.
Excellent. And ascorbate, if I understand properly, is the form or the metabolite of vitamin C that the body uses. It's the physiological form. Is that correct?
Well, yes, thanks for asking, Susan. You have ascorbate, and that is the preferred form. Then you have DHA, dehydroascorbate.
Right.
Which is a reversible oxidation. So when ascorbate donates its energetic electron, it becomes DHA.
Right, when it becomes oxidated.
Yes, so the first is a reversible oxidation, not a harmful oxidation, to produce a reversible form called DHA, which is more easily taken up by cells, is used inside of cells to help regenerate ascorbate.
Right, and the capacity to regenerate ascorbate partly determines the half-life of ascorbate in the body, I wonder. People vary in their ability to regenerate ascorbate.
So yes, in biology, in life, there are 3 forms, starting with ascorbate, that is the active mother molecule, the antioxidant that sacrifices herself that all others can be regenerated. Then you have the reversible healthy intermediary called DHA, dehydroascorbate, and the biology of the body is to go back and forth between ascorbate and dehydroascorbate because that is reversible, regenerative, healthy. On the other hand, when cells lack magnesium and therefore are too acidic, when cells lack the other essential nutrients, then a double oxidation occurs, and now you produce diketogulonic acid, DKG, diketogulonic acid, which must be excreted from the body because it will harm the body if it builds up.
Right, perfect.
And not too long ago, there was a company that was producing or selling commercial grade ascorbate, and they made a virtue out of having diketogulonic acid in their product. And do you know that that company went out of business? For good reason. Because diketogulonic acid is not what you want. You want the ascorbate. You want it to go back and forth from AA, ascorbic acid is AA, to DHA, dehydroascorbate. It's a dance. It's a reciprocity. Yes.
And you need the nutrients, to the magnesium in the alkaline environment to do that.
You must have the magnesium in the cell because 1 molecule of magnesium is needed per molecule of ATP for the ATP to work.
Right.
So we know how important ATP is, but we seem to forget that in order for the ATP to work, you have to have an alkaline environment, what we call the alkaline milieu, that supports the proton gradient. They gave Mitchell the Nobel Prize for the proton gradient, without which the battery slows down and shuts down. So the fact that many people are easily fatigued is because they're dependent on anaerobic Embden-Meyerhof glycolysis to produce energy, and their mitochondria is not working because the proton gradient has collapsed because of a lack of magnesium. And then people take a bunch of magnesium, get diarrhea, and run away from the person who recommended it. But of course, we have enhanced the uptake of magnesium to near 100% by combining the biological forms of magnesium with choline citrate, which we've been offering for decades, which you have been among those who have documented, that you triple the uptake of magnesium. You don't get the irritability and diarrhea that's associated with all magnesium. Magnesium at most is taken up by 1/3 unless you add choline citrate. So 1/3 is the maximum uptake, and 3% is common. So most of the magnesium stays in the gut and irritates, and we don't recommend that. We want to give the available magnesium with the choline citrate to get it in and to document it based on the first morning urine pH that there is sufficiency to restore the proton gradient in the cell.
Okay, excellent. Thank you very much. Now, just one other question about ascorbate here. So we have found over decades that a fully buffered ascorbate, like the product that we use, is a very effective alkalizing agent. It can donate either 1 or 2 electrons, as I understand. It's like a carbonate or a citrate. Now, ascorbic acid, I see ascorbic acid as acid forming. Is that correct?
Yes, when you say ascorbic acid, you're not talking about perc potent Seagard.
No, there's another molecule that's a...
No. There has to be a counter ion. When we say fully buffered, we mean counter ions. And we specifically have 4 by design: potassium, calcium, magnesium, and zinc. So whether a person needs 1 gram, 10 grams, or 100 grams, they get the beneficial minerals that they need to take advantage of the ascorbate. So ascorbate is not ascorbic acid. Ascorbic acid is acidic and not recommended. Ascorbate is buffered and recommended because you need both the minerals and the vitamin C.
Yes. And it's sort of interesting. The public perception is that ascorbate is the same as a vitamin C. And I look up the chemical structure. They're different molecules. One is protonated, one isn't. So it's like, we just want to understand that so we can help the public understand that these are 2 different substances we're talking about. Vitamin C, ascorbic acid, and ascorbate.
Yes, as I learned from Bob Cathcart and Linus Pauling, and as he learned from Irwin Stone and others, and Albert Szent-Györgyi, we can be confused by nomenclature that is obscure, the biochemist language, and I'm a recovering biochemist.
Right.
On the other hand, when people who don't understand the subject talk elegantly but confusedly, it is unhelpful to the consumer.
Right.
If it says ascorbic acid, it's an acid and not recommended. If it says ascorbic acid, it's probably synthetic.
Right.
I mean, almost certainly synthetic, almost certainly not recommended. Because when we say synthetic, what we mean is half is the healthy form, the L form, and half is the D form, which builds up in your gut and irritates you.
Yes. I appreciate you taking the time because we spent a little bit of time. We've used these products for decades, the buffered ascorbate, with great results. Now I'm starting to understand the chemistry a little more, and I feel very confident now in helping people understand the difference between.
Yes, and anyone like you who wants to dig into the details, go back to the article that Sam Seifter wrote in Annual Reviews of Nutrition in 1987. 1987. He was really prescient, but it's a really beautifully written. I don't mean just brilliantly, because he was brilliant, but he was also a good writer. Actually, his colleague Sasha was the editor. But the point is that there is lots of confusion and very little understanding.
Great.
And 95%, and I know you know this Susan and Jay Shree, but 95% of the vitamin C or ascorbate that is sold is synthetic.
Right.
And it's a work-alike that doesn't work. So we decided when I pioneered the concept of all actives all the time to make sure that if it was a work-alike, that it really worked. And 100% of the time, the work-alike, the synthetic version, doesn't work, partly because half of it is not biological. So it turns out the inexpensive vitamin C, the inexpensive ascorbic acid, is only at most half L form. That means useful.
Yeah.
So now you have to double the price. And then much of what is the L form has been damaged by air oxidation because oxygen is a powerful oxidizing substance.
Right.
And you really don't know what you have because you do have some damaged molecules. You have some diketogulonic acid you have to get out if it comes in. And so I think it is fair to educate people that biology, there is a reason, Susan, and I think you know this, but I want everyone to understand, there's a reason why the chemistry department is on the main campus of the college and the biochemistry department is in the medical school. Mm-hmm. So synthetic chemists on the main campus say, oh, vitamin C. But they forget to mention that half of it builds up in the gut and irritates and doesn't get absorbed. That's the D form. Only half of it would be active if they had excluded oxygen, but some variable amount has now been irreversibly damaged to the point where you get very little actual benefit from these synthetic but commonly and commercially available forms of vitamin C.
Would that be the reason why some people also say that you can absorb only 500 milligrams at a time? I know.
Yes, there are people who point out that when the D form builds up in your gut, it causes agina, discomfort, diarrhea, etc. Therefore, the human body can only take up small amounts of vitamin C at a time. That is true of the synthetic form. But as we know from the C-cleanse experience, sometimes just 3 to 5 grams is enough to cleanse, and sometimes 30 to 50 grams is needed. I was talking with a dear friend, Sue Radcliffe, who we've known for a long time, and she had an incident in a dentist's office, and she went home and took 90 grams of vitamin C and began to feel better, but she had never needed more than 10 or 20 in order to cleanse.
Yeah.
So yes, when you use a synthetic work-alike that doesn't work, you're compounding confusion with misunderstanding.
Right. And this thing of plasma level, they say the plasma level peaks at 500 milligrams or perhaps 1,000.
Well, no. Actually, Hugh Reardon, my colleague in Wichita, Kansas, showed many years ago, and Ron Honeyhockey has continued his work since his passing. When you talk about intravenous vitamin C, which is another level and a completely different conversation, but when you shift the conversation to intravenous vitamin C, now we know what the peak and trough levels should be. 50 to 80 milligrams per deciliter peak, that means right after the infusion from the contralateral arm, and 10 to 20 milligrams per deciliter before the next infusion, meaning a continuous, adequate therapeutic level of vitamin C. Mm-hmm. And by the way, interesting is that when you give, say, 100 grams of vitamin C by vein slowly and safely and effectively, you get no GI discomfort. Mm-hmm. Mm-hmm. So yes, we know that when we give by vein to get maximum therapeutic benefit, and usually these are people with serious life-threatening illnesses, the peak level after infusion should be 50 to 80 milligrams per deciliter. The trough level should be 10 to 15 milligrams per deciliter. This is done as a form of modified hyperalimentation. Now let's get back to oral. When people do the C-cleanse, and I think we reported something over 4,000 consecutive reports from various different colleagues, but what we found was some people who were really healthy and asymptomatic, they didn't need much of nature's ascorbate, the fully buffered, fully reduced L-ascorbate. I mean, like 4 or 5 grams to flush. People with minimum symptoms needed 5 to 10 grams. The majority of people needed 10 to 100. And then some people needed more than 100 grams to cleanse. Mm-hmm. And so over the decades, we have learned two things. One, how safe and effective the C-cleanse is. And number two, that as my grandmother used to say, the rents are going up and the ceilings are coming down. And what she meant by that was the need for ascorbate is going up and the availability of ascorbate is going down.
Right.
What we have seen over the decades with many, many, many people.
Yes, 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 yes.
This is not a prospective study.
Mm.
This is hundreds of colleagues reporting spontaneously that following our guidance, they were able to achieve results that otherwise they could not get.
Right, right.
By respecting physiology, by understanding the difference between the effective dose and the toxic dose. And we always use the natural, safer form because it's more effective and less toxic.
Yeah. Yes, exactly. Thank you. Thank you again.